This question is about vectors. Relative to the origin O, the points A, B, C have position vectors given by OA is 2, 1, 3, OB is 4, 3, 2, and OC is 3, minus 2, minus 4. The quadrilateral ABCD is a parallelogram. Part A, find the position vector of D, 3 marks. So the best way to do this kind of question, in my opinion, is to start by drawing a parallelogram, label the vertices A, B, C, D, and just rewrite the coordinates or the position vector. A is 2, 1, 3, B is 4, 3, 2, C is 3, minus 2, minus 4, and then just look at the process as you go from B to A. So if you want to go from 4 to 2, of course the process is minus 2. So minus 2 plus 1. This is the process from B to A. And since it's a parallelogram, they are parallel, of course you gotta do exactly the same thing if you want to go from C to D. So also minus 2 plus 1. So to find D, 3 minus 2 is 1, minus 2 is minus 4, minus 4 plus 1 is minus 3. That's how you can find the coordinates or the position vector of D. Next part, the angle between BA and BC is theta. Find the exact value of cos theta, 3 marks. So in the MPF 19, you can see this formula. Now if you rearrange this formula, you're gonna get, well, cos theta equals A dot B, the factor A dot the factor B divided by the magnitude of A, magnitude of B. Okay, so this is the MF19 formula. If you rearrange a little, you're gonna get this kind of formula. So using this formula to find the angle between BA and BC, I suggest you to write or to draw a simple diagram. So you're finding BA and BC. BA and I mean the B is in the middle here, so BAC. This is the angle you are looking for. BA is in this direction, BC is in this direction. So if you want to find the angle between BA and BC, you gotta be careful. You gotta use the factor BA and BC. So the factors should start with the same point, because if you use CB instead, you're not gonna get the angle between BA and BC actually. So just remember, the arrows should start with the same point, which is the vertex of the angle you want to find. So if one angle is in this direction instead, it's gonna be wrong. Okay, so we need the factor BA and BC and the magnitudes of BA and BC. The factor BA is the coordinates of A minus the coordinates of B. So OA minus OB. We know that this is OA, this is OB, so you subtract, you get 2 minus 4, 1 minus 3, 3 minus 2, so you get minus 2, 1. So that's the factor BA. To find the magnitude, we use like a Pythagoras here, so the square root of the square of each component, and you add everything. So you get 4 plus 1, which is 9, square root of 9 is 3. To find the factor BC, same concept, coordinates of C minus coordinates of B. So you subtract 3 minus 4, minus 2 minus 3, minus 4 minus 2, you get 3 minus 4 is minus 1, so minus 1, minus 5, minus 6. Minus 1, minus 5, minus 6 is the factor BC. The magnitude of BC is, again, square root of, you get 1, 25, 36, so 62. Now you have everything you need to find the dot product. this is dot product. If you look at the formula to find the dot product, you gotta do a1 b1. So this is a1, this is b1. So basically the product of each components. So -2 -2 1 dot -1 -5 -6 divided by the magnitude, which is 3 and root 62. So you multiply each component. -2 times -1, you get 2. -2 times -5, you get 10. 1 times -6, you get -6. And use a calculator, simplify, you're gonna get, this is 6 over 3, which is 2, so 2 over root 62. This would be the final answer. It says exact value, so don't round off and use 3 significant figures or something. Next part, hence find the area of ABCD, giving you an answer in the exact value, 4 marks. So if you want to find the area of ABCD, you can use BABC, magnitude of BA and magnitude of BC, sine theta, because we have this formula to find the area using this length and this length and this angle. So this is called the sandwich rule. So this length times this length times the sine of the angle divided by 2. So that's the area. 1/2 times the length AB, the length BC, times sine theta. But since we are looking for the area of the whole parallelogram, of course we're going to have to multiply by 2. So 2 times, they cancel out, we have only BABC sine theta. We have the magnitudes of BA and BC already before from the previous part, magnitude of BA and BC. And to find the sine theta, remember this is actually cos theta. So to find the sine theta, you can just draw a simple triangle, label it theta. You know the cos is 2 over root 62. And if you use Pythagoras, you're gonna get 62 minus 4, which is 58 square root. So this will, using Pythagoras, you get root 58. So sine theta is opposite over hypotenuse, root 58 over 62, cancel out, and you get the final answer in this form. So that's the final answer, 4 marks. Alright, I'll see you again next time.